The heights and feet of 36 randomly selected top-rated roller coasters are listed below. Assume the population standard deviation is 71.6 feet. At alpha equals 0.05, is there enough evidence to reject the claim that the mean height of top-rated roller coasters is 160 feet? Part A. Identify the claim and state the null and alternative hypothesis. Let's highlight the claim. The claim is that the mean height of the top-rated roller coaster is 160 feet. How would we write this using mathematical symbols? We could say that mu equals 160. Notice that this one has an equal sign in it, therefore this one must be the null hypothesis. Remember that the alternative hypothesis is going to be the complement, or what's opposite. Part B, find the standardized test statistic. For this one, we're going to use Google Sheets. Recall that the formula for finding the standardized test statistic is x bar minus mu divided by sigma divided by the square root of n, where n is the sample size. We're going to use Google Sheets to calculate the mean of the sample, and then we'll also use it to calculate the z-test statistic. Here I have Google Sheets opened up, and I already have my data entered. So the first thing I want to do to calculate that z-test statistic is to calculate the average, or the mean of my sample. Remember that to find the mean is the same as finding the average using the average function. So we're going to select the average function, and then we're going to highlight our data. Notice that it doesn't matter that my data is not in one single column. I can use it even though it's not in one single column. Now that I have my average, I'm going to calculate my z-test statistic, or my standardized test statistic. And this is going to equal, I'm going to use parentheses to enclose my numerator, the sample mean minus the mean that we're going to be testing. I'm going to enclose that in parentheses, then use the slash for the division sign, and again I'm going to enclose the denominator in parentheses, since in that denominator I have a division. Your standard deviation divided by the square root of your sample size, and your sample size here is 36. And then enter. Here I have my standardized test statistic. So using Google Sheets, we found that our test statistic is approximately equal to 0.39. Part C, find the corresponding p-value. Now, before we actually use Google Sheets to calculate the p-value, I want to get you to have a visual of where this is on the standard normal curve. So let's draw a picture. Remember that in standardized z-scores, this is 0. So 0.39 will be somewhere around here. Now recall that this is going to be a two-tailed test since my null hypothesis had an equal sign in it. So it's two-tailed. So you know that whenever we find our p-value, or the area under the tail, we're going to have to multiply that by 2. Okay, it's because we're finding the p-value of a two-tailed test. So just recall that. Now, when you are looking at the table, or you're using Google Sheets to calculate the area under the curve, you are always going to get the area that's to the left. Now, think about it this way. We need the area that's to the right because we need this area that's in the tail. So what we're going to do is we're actually going to look up or use the negative 0.39 to find the area that's in this tail, because our standard normal curve is symmetric. That means that this area here is the same as the area on the tail on the right side. So again, we're going to look up negative 0.39, or we're going to use Google Sheets to find the area under the curve to the left of negative 0.39. Then we'll take that number and multiply it by 2 to find our p-value since this is a two-tailed test. Okay, so I'm back at my Google Sheets page, and I'm going to calculate the p-value. So we're going to type in equals 2 times, since this is a two-tailed test, norm, and we're going to select the norm S distribution. This is because our standardized test statistic is that it's standardized. Then we're going to type in a negative sign because we want the negative version of our standardized test statistic. Enter. We can see that our p-value is approximately 0.6992. Part D. Decide whether to reject or fail to reject the null hypothesis. To do this part, let's recall our rules about comparing the p-value and alpha. If the p-value is less than or equal to alpha, then we reject the null hypothesis. If the p-value is greater than alpha, then we fail to reject the null hypothesis. So let's compare our p-value and our alpha. Our p-value we said was 0.6992. And alpha here is 0.05. We can see that our p-value is significantly more than our alpha. Therefore, this falls under the second category, and we fail to reject the null hypothesis. Part E. Interpret the decision in context of the original claim. Let's look at what the original claim was. The original claim was actually our null hypothesis, and that was the mean height of top-rated roller coasters is 160 feet. So remember that we failed to reject the null hypothesis, which means that we're stating that our null hypothesis is true. So let's look at the question. The question was, is there enough evidence to reject the claim? So we would say, in response to that particular question, there is not enough evidence at the 5% level of significance to reject the claim that the mean height of top-rated roller coasters is 160 feet. Now let's look at an example where we're using the rejection region to make our decision. A fast food restaurant estimates that the mean sodium content in one of its breakfast sandwiches is no more than 920 milligrams. A random sample of 44 breakfast sandwiches has a mean sodium content of 925 milligrams. Assume the population standard deviation is 18 milligrams. At alpha equals 0.10, do you have enough evidence to reject the restaurant's claim? Identify the claim and state the null and alternative hypothesis. Let's highlight the claim. The claim is that the mean sodium content in one of its breakfast sandwiches is no more than 920 milligrams. No more than means that it has to be less than or equal to 920 milligrams. Notice that this one has the equal sign attached to it. Therefore, this one has to be the null hypothesis. The alternative is going to be the complement, or that mu is greater than 920. Part B, find the critical value. Now, we've already gone over how to find these critical values in the table, but I would like to draw your attention to a particular page in your textbook. Remember that you're allowed to have your textbook for the final exam, so this is a really great tool to have at your fingertips. Look on page 369 of your textbook. You're going to find a little table that says under study tip. And they have listed out several critical values that are commonly used. So we're looking at alpha equals 0.10, and Notice that this is going to be a one-tailed test. So let's figure out, is it a right-tailed test or is it a left-tailed test? To figure that out, let's look again at our alternative hypothesis. The alternative hypothesis was that mu is bigger than 920. So since our inequality sign is a greater than sign, this is going to be a right-tailed test. So looking at the little chart, we're looking at alpha equals 0.10, and I'm going to look for the right-tailed test, and I see that the z-score is going to be 1.28. So that's going to be my critical value. Part C, find the standardized test statistic. Let's look at the formula for finding the standardized test statistic. This is z equals x bar minus mu divided by the standard deviation divided by the square root of n. Let's plug in our numbers that we have. X bar is the mean from your sample. Mu is the mean that we're testing. Standard deviation is 18. And our sample size is 44. I'm going to simplify the numerator and I'm going to simplify the denominator. 925 minus 920 is 5. And then 18 divided by the square root of 44 is 2.714. And this is approximately equal to 1.84. So my standardized test statistic is 1.84. Part D. Decide whether to reject or fail to reject the null hypothesis. So to do this, let's first look at our standard normal curve. Now what I'm going to do is I'm going to plot my critical value on here, 1.28. Now I'm going to shade my rejection region. My rejection region is the tail area, or the area under the tail. Now on this same graph, let's plot our standardized test statistic. And we found that that standardized test statistic was 1.84. Notice that I plotted 1.84 in that rejection region. Therefore, I'm going to reject the null hypothesis. Now I'm going to interpret my decision in the context of the original claim. The question is, do you have enough evidence to reject the restaurant's claim? Yes, I do have enough evidence to reject the restaurant's claim. So how do we put that in words? The answer would be, there is enough evidence at the 10% level of significance to reject the restaurant's claim that the mean sodium content in one of its breakfast sandwiches is no more than 920 milligrams.